The really interesting thing to me about number 4 is, remember, those are called composite figures. It's when I take two 3D solids, I put them together, pretend like you're in welding class, I weld it to where it is not two shapes anymore. It is one shape. And what's interesting to me about number 4 is that, you know, when you have a cone, the lateral surface area is this face right here. The total surface area is this face plus B. Now, when I don't have two cones, but when I put two cones back to back, like in number 4, I get rid of both of my B's. There's no B at all. There's no B on the surface. So what I'm really doing is I'm going to find the LA of this guy, and I'm going to find the LA of this one, and that's the total surface area. So for number 4, the SA and the LA are the same thing. The SA and the LA are the same thing. Now, this formula is really simple. Pi r L. We already know R is 8. R is 8 for both of our cones. So we are in good shape. We don't have to figure that one out. Now let's find L, which stands for the slant height. Don't use 15 and 18. Those are not the slant heights. So we're going to do our good old Pythagorean theorem. 15 squared plus 8 squared, square root, and it is a triple. Yay! So 17. So that's L for this one. All right, now for our other one, the end of the story is not that good. So when I do 8 squared plus 18 squared, I get 388. And then I have to factor tree that. But when you do factor tree 388, you get 2 root 97. I'm sorry, I did not make up this problem. Yes, that is not pretty. I agree. Okay, so for the lateral surface area, I'm kind of running out of room. I'm going to do pi times r times L plus, add them together, pi times r times L. Now, you're tempted to think that these are like terms because they both have a pi in them. But they're not like terms because one has a radical and one doesn't. So we can clean this up, but we cannot combine those into one term. 8 times 17 is 136. So there is the LA of cone number 1. 8 times 2 root 97 is 16 root 97 pi. I'll just write on top of my pi I had earlier. Okay, ugly answer, but do you see where it comes from now? For the volume, same thing. You find the volume of one, you find the volume of the other, and you add them together. There's nothing special on the shape where you have to like not count one of the bases or anything like that. Volume is going to be prettier. Volume is area of the base times the height. So the volume would be pi r squared h plus pi r squared h. So the volume is just a matter of multiplying those things in your calculator. 8 squared times 15 plus 8 squared times 18. These are going to be like terms. They're both an integer times pi, an integer times pi. So that's how I get 2,112 pi centimeters cubed. And this one was centimeters.